A study on characterization of a 430L ferretic stainless steel by using powder metallurgy. We we are done in project in college where my batchmate names Vijay Kumar Keshri, Gautam Kumar Pathak and Anup Pradhan. Then come to the introduction part. Steel. The term steel generally refers to the different alloy of iron. These alloy vary by means by way they are formed and also by the properties of the materials added to the iron. All steels, however, contain little amounts of carbon and manganese. In alternative terms, it is said that steel is nothing but a crystalline alloy of iron, alloy of carbon and several other components that harden higher than its critical temperature. It is most commercial steels are classified into two groups: plain carbon steels and alloy steels. Limitation of plain carbon steels. This is the basic one. Basic. Uh, there cannot be the strength beyond 100,000 without having any significant loss in toughness as well as ductility. Large sectional area cannot be formed with a martensite structure throughout and therefore don't found to be deep hard enabled. General effects of the alloy components are the improved tensile strength without any appreciable reduction in ductility, improved toughness of material, improved hardenability, the alloy hardening of large sections than attainable with the plain carbon steels as alloy quenching with the less drastic rates. Alloy steel. It is nothing but based on the features of alloying elements. Alloy steel can be classified as the two types: low alloy steel and high alloy steel. Low alloy steel is total alloy element less than 10%, and the high alloy steel is content above 10%. We discuss about the heat treatment of steels. Heat treatment is the method of heating and cooling of metals to attain the desired physical and mechanical properties through modification of the crystalline structure. The temperature, time, duration and cooling rate after heat treatment will have the dramatical impact on properties. Basically, heat treatment stages. Heat treatment is various stages: heating the metal to the specified temperature. Second stage is the soaking, holding the metal at the temperature for a specific period of time. Third stage is cooling the material to again room temperature. This is the basic. Then we go to next stage: types of heat treatment. Annealing. Annealing is the heat treatment process with which the metal is heated to a specific temperature and cooled at a defined rate of produce defined microstructure. It helps the metal to be used for cold working by making it the softer, enhances much inhabitability to air to improved electrical properties. Normalizing. Main purpose to in fact in unfortunately in grain size as well as the composite throughout and the alloy. Generally in this process ferrous alloy is heated above the upper critical temperature followed by cooling in the open air. This is the basic definition of normalizing. This graph is full annealing, normalizing and the superwelding. By the composite and the graph versus composite and the temperature. Quenching. What is quenching? In this process, the metal is cooled in the rapid rate resulting in the martensite transformation, resulting in hardened metal in case of ferrous metal, softer than normal in case of non-ferrous metal. What is tempering? Tempering is nothing but the molten steel formed after the quenching is a very hard and the brittle, so they cannot be used in any application. This problem is solved. This problem is solved by tempering. This is the basic triple. This is the basic triple T diagram of the steel for the heat treatment process. This is the methods and methodology of the powder metallurgy. First method is ball milling. A ball milling, what is ball milling? A ball mill is the type of grinder used to grind material into extremely fine powder for using mineral dressing process, paints, uh, ceramics, and the selective laser sintering. A ball mill works on a principle of impact, and the iteration size reduction is done by impact as the balls drop from near the top of the cell. This is the specification of the ball mill. Number of balls is 34, diameter of a ball is 10, a speed ratio is 1:2, and its sun wheel speed is 1000 rpm. Effective sun wheel diameter is 141, like that. This is the basic diagram of the rotation of the grinding wall by using the industry and the various applications. This is the sintering process. Sintering is the loose a compact metal powder 0.7 to 0.9 base metal of the melting point with and without addition of pressure. This is the basic definition of sintering. Sintering temperature for stainless steel 430L is the 1100 degree centigrade for steel. Sintering happens naturally in the mineral deposit as a manufacturing process used with the metal, ceramics, plastics, and other materials. This is the vacuum hot press by using the done sintering process. This is the sample of the sintering after completion sintered materials. This is the sintering graph, temperature and hours. After completion, we draw the sintering graph. This is the sintering process done. After that, this is the result and discussion. Characterization of mechanical of alloy powder. The main result is the mechanical alloy powder where the analyzed by X-ray diffraction, SEM and particle size analysis is understand the topographical characterize and the get information about elements and phases present in the powder after different hours of milling. Crystalline size and the strength the milled powders were calculated by using Williamson-Hall equation. The lattice parameter of the powder was also calculated by using Nelson relay function. Mechanically alloy oxide dispersion as strength MaODs ferrite alloy as the attractive for fusion reactor applications. The microstructure stability we gain the result Fe 14% weight and chromium 3%, titanium 0.3%, like that. This is the basic graph of the X-ray diffraction. X-ray diffraction exciting characterization were carried out for identification and phase defection. This is the graph of XRD patterns of a different milling intervals. 4 diagrams used for after getting the XRD diffraction patterns for different milling powder. This is the crystalline size and lattice strain calculation formula. This is the SEM diagram. This is the S.
क्या है ऐसा क्या इम्पोर्टेंट काउंटर
Yeah. This is the hardness determination graph, rigorous hardness and the samples. This is the conclusion future work of the project. The project report includes a detailed microstructure characterization of the austenitic and the ferretic stainless steel powder, synthesized by the mechanical align in the high energy planetary mill, and the determination of the crystalline size, lattice strain and lattice parameter. This is the basic conclusion. First, basic important conclusion is it is possible to synthesize a nanostructure stainless steel powder by the mechanical align by using the high energy planetary ball mill. As the milling time increases, the particle size decreases first and then becomes nearly constant afterwards. This is because after a certain interval, time
क्या कहते हैं
static state.
क्या है